Hi students, welcome to Renju at Physics. Today we are going to discuss an important topic, that is Coulomb's law of electric forces. Okay, today we are going to discuss Coulomb's law for finding the force between charge at rest. In 1785, the French physicist Coulomb experimentally derive an equation for finding the force between charges. For that he considered two charge sphere. He considered that charge sphere as a point charge. He considered two point charges Q1 and Q2 as separated by some distance. So here this is a charge Q1 and this is a charge Q2. Is a point charges, they are separated by a small distance r. So there will be an interaction between Q1 and Q2. Okay, there will be interaction between Q1 and Q2. That means it may be the force may be attractive sometime, force may be repulsive sometime. So if is Q1 Q2 is greater than 0, the force will be repulsive. If Q1 Q2 is less than 0, the force will be attractive. Q1 Q2 greater than 0, the force will be repulsive, and Q1 Q2 is less than 0, force will be attractive. Okay, so here there will be a force of interaction according to Coulomb's. The force of interaction F is proportional to Q1 and Q2. The force between these two charges is directly proportional to product of magnitude of these two charges, and F is proportional to 1 by r square. The force is inversely proportional to the square of distance between them. So Coulomb says that the force of interaction between two charges separated by some distance, that force of interaction is directly proportional to product of their charges and inversely proportional to square of distance between them. So Coulomb's statement is like that: the force of interaction between two charges or any charges is directly proportional to product of their charges and inversely proportional to the square of distance between them. This law is called Coulomb's law. So we can represent this mathematically. Here F is proportional to Q1 Q2 and F is proportional to 1 by r square. Clubbing the equation, these two equations, we can write F is proportional to Q1 Q2 divided by r square. So we are clubbing these two equations, we can write F is proportional to Q1 Q2 divided by r square. Actually these two charges is placed in a free space. The medium is vacuum. Here is no medium, here is free space. So the force is given by F is proportional to Q1 Q2 divided by r square. So in order to remove the proportionality, we multiply by a constant k. So this equation become F is equal to K Q1 Q2 divided by r square. But the value of K here is equal to 1 by 4 pi epsilon 0. Here epsilon 0 is the permittivity of free space. 1 by 4 pi epsilon 0, here epsilon 0 value, epsilon 0 is a permittivity of free space. The value of epsilon 0 is, epsilon 0 value is 8.854, 8.854 10 raised to minus 12 Coulomb square, Newton raised to minus 1, meter raised to minus 2. That is the unit of epsilon 0. So we substitute this value here instead of this k, we get F is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by r square. So this is the equation for finding the force between two charges kept at a particular distance in free space. That is F is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by r square. So we can say, we can conclude the law. The Coulomb's law states that the force between any two charges is directly proportional to product of their charges and inversely proportional to the square of distance between them. So this is the Coulomb's law. From this is found that when the separation increases, separation between charges increases, the force of interaction will be decreases because it is inversely proportional. If R is increases, the force will be decreases. If Q1, Q2 is increases, the value of Q1 and Q2 is increases, we can say the force will be increases. That is directly proportional. If the operation between Q1 and Q2 is less, mean the force of interaction will be more. So that's about the Coulomb's law of electric forces. Suppose these charges are placed in a medium. Okay, suppose the charges are placed in a medium. The force of interaction between the charges can be represented by Fm equal to 1 by 4 pi epsilon Q1 Q2 by R square. Here epsilon is the permittivity of that medium. Epsilon is the permittivity of the medium. So we know that when the charges are placed in a vacuum, so this is the equation for finding the force of interaction when the charges are placed in a free space, and this is a charge. This is the force of interaction between the charges when kept in a medium. Suppose we divide these two equations F and Fm, F by Fm, we get epsilon by epsilon 0. So that is given by epsilon R, that is equal to, or we can call it as K. So epsilon R or K is called relative permeability. So the epsilon by epsilon 0 is called relative permittivity, or otherwise the force of interaction between the charge in free space to the force of interaction between the charge in medium is called relative permittivity or dielectric constant. From this we can write the force between the charge in a medium is equal to 1 by K times of force. When the dielectric, suppose we are keeping some dielectric medium between the charges, the force of interaction will be decreases, Fm equal to F by K. Okay, this is the equation for finding the dielectric constant or relative permeability. From this we can define the relative permeability or dielectric constant. It is a ratio of permittivity of medium to permittivity of free space. So otherwise the force of interaction between the charge in a free space to the force of interaction between charge in free space to the force of interaction between the charges in a medium, that is also called dielectric constant. So from this we can affirm F is equal to F by K. Here F is the force interaction between charges in a free space and K is the dielectric constant. So next we are going to discuss about the vector form of Coulomb's law. We are going to discuss the vector form of Coulomb's law. So we consider two charges. We are going to discuss the vector form, how we can represent the Coulomb's law of force in a vector form. So we consider two charges. This is a one charge Q1 and is another charge Q2. Is placed in a coordinate system X, Y, Z. This is the origin, and we draw the position vector. Here R1 is a position vector of Q1 and R2 is a position vector for Q2. Okay, so this is a separation between Q1 and Q2, and here we consider R1 vector is a position vector for Q1 and R2 vector is the position vector for Q2. Okay, so here we consider F12 vector. F12 vector is the force on Q1 due to Q2. F12 represent the force on Q1 due to Q2, and similarly F21 represent the force on Q2 due to Q1. So R12 is the force on Q1, R12 is the force of Q1 due to Q2, and F21 is the force on Q2 due to Q1. Suppose we consider these two charges Q1, Q2 is greater than 0. So force between the two charges will be repulsive. So we can represent the force on Q1, it will be in this direction, that is F12, and force on Q2 is in this direction, F21. Here we are using certain unit vector for represent the direction. Here R12 vector, sorry, R12, the unit vector R12 represent the direction from 2 to 1 or Q2 to Q1. And here the unit vector R21 cap give the direction from Q1 to Q2. Okay, so we consider two charges Q1 and Q2 in a coordinate system. Here R1 and R2 the position vector for Q1 and Q2. Here we represent F12 the force on Q1 due to Q2 and F21 is the force on Q2 due to Q1, and here we are using a unit vector R12 is the direction from Q2 to Q1 and R21 is direction from Q1 to Q2. Here R12 unit vector is equal to R12 vector divided by R, and R21 unit vector is equal to R21 vector divided by R. Here the magnitude of R12 vector is equal to magnitude of R21 vector is equal to R. Okay, that's why we got it is like this. R12 is equal to R12 vector by R, R21 equal to R21 by R. So we can represent the force between the charges. So we know that in general the force between the two charges is given by F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. So this is the general equation we use for finding the force between two charges. So first we are going to represent the force between, first we are going to find F12, the force on Q1 due to Q2, that we are going to find out first. The force on Q1 due to Q2, that is given by F12 is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. In which direction the force is acting, that is R12 cap. R12 cap represent the direction from 2 to 1. So F12 means the force of 1 by 2, that is F12 is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square R12 cap. And similarly we can write F21, that is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R square into R21 cap. Here F21 is the force on 2 by 1, so 4 pi epsilon 0 Q1 Q2 R2 the force on 2 by 1, that is R21 cap. So this is the vector representation of Coulomb's law of forces.